Imagine standing on a familiar beach, listening to waves that seem ancient and patient. Now picture this quietly unsettling thought. Beneath that water once lay forests, rivers, villages, entire worlds that never expected to drown. If this helps you fall asleep, perfect. The ocean has been putting people to sleep for about 12,000 years. Tonight is simply another chapter, tracing how ice melted, seas rose, worlds vanished, and somehow we stayed. Before you drift any deeper, if this quiet helps you feel safe tonight, you're welcome to stay with us. Subscribing softly keeps this place gentle and lets these nights continue. Now, rest. To begin, we step quietly into the first chapter of our journey backward through history, into a world that was not just cold, but fundamentally different. When people imagine the Ice Age, they usually picture something familiar but exaggerated, a version of today with more snow, longer winters, thicker coats, maybe a few dramatic glaciers sliding lazily through valleys that are now green. It feels intuitive, comfortable even, a colder Earth, but still recognizable. That picture is wrong in almost every meaningful way. The world 20,000 years ago was not simply cold. It was reorganized. Temperature is the least interesting part of the story. What mattered was where the water was, where the land was, and how gravity, ice, and time had quietly rearranged the surface of the planet into something we would struggle to recognize today. Start with the ice itself, not mountain glaciers, not seasonal snowfields, continental ice sheets, vast continuous bodies of frozen water that covered entire countries and pressed the Earth's crust downward under their weight. In North America, the Laurentide ice sheet extended from the Arctic Ocean all the way down past modern New York City and Chicago. In Europe, the Scandinavian ice sheet buried Scandinavia, the British Isles, and stretched deep into northern Germany and Russia. These were not thin layers. In many places, the ice was between 2 and 3 kilometers thick. That number is difficult to feel in your body, so let's be gently unreasonable about it. Imagine stacking familiar buildings, a cathedral, an office tower, another office tower. Keep going. You would still not reach the surface of the ice. If you wanted to visit London 20,000 years ago, you wouldn't need a passport. You'd need a shovel, several miles long. And the ice was not passive. It was heavy, incredibly heavy, so heavy that it pushed the Earth's crust downward like a thumb pressed into soft clay. In regions that were once under ice, the land is still rebounding upward today, rising millimeter by millimeter, as if the planet is slowly exhaling after holding its breath for thousands of years. This is not a metaphor. It is a measurable process called isostatic rebound. The Earth is still adjusting to the Ice Age. The Ice Age, in that sense, has not fully ended. Now consider where all that ice came from. Water does not appear out of nowhere. Every drop locked into those ice sheets was once part of the ocean. Over tens of thousands of years, moisture evaporated from the seas, fell as snow, and never melted. Year after year, snowfall accumulated faster than it could disappear. The planet ran a long, quiet experiment in water storage. By the peak of the last glacial maximum, roughly 50 million cubic miles of water were trapped in ice, removed from circulation, taken off the playing board. The ocean was smaller because it had been quietly drained. As a result, global sea levels were approximately 120 meters lower than they are today. That number matters more than temperature ever could. 120 meters is not a slightly wider beach. It is a fundamental redrawing of the world map. Entire continental shelves were exposed, not rocky margins or empty flats, but vast landscapes with rivers, forests, wetlands, and grasslands. Places where people lived. Places that were, by any reasonable ecological standard, some of the most productive environments on Earth. The coastline was not where you think it was. It was often dozens of kilometers farther out, sometimes hundreds. Stand on a modern beach and imagine walking straight out into the sea. Keep walking. When the water reaches your knees, keep going. When it reaches your chest, continue. When you finally vanish beneath the surface, keep descending. Only then, far below the waves, would you reach the ground level of the Ice Age coast. This is why maps from 12,000 years ago would be unrecognizable to us. Britain was not an island. Southeast Asia was not a scattering of islands. The Persian Gulf was not a gulf. The North Sea did not exist. These are not poetic exaggerations. They are geological facts. And importantly, these exposed lands were not marginal. They were not frozen wastelands clinging to survival. Many of them had relatively mild climates buffered by proximity to the ocean. They had access to fresh water, rich soils, abundant plant life, and an extraordinary diversity of animals. They were attractive places to live. So humans lived there, in significant numbers. This creates a quiet problem for how we imagine Ice Age humanity. We tend to picture small, scattered bands, barely surviving at the edge of habitability. But the archaeological and genetic evidence increasingly suggests that late Ice Age populations were larger, more stable, and more interconnected than we once believed, especially along coastlines. Coastal zones offer food security. If the hunt fails, the sea remains. Shellfish do not migrate. Fish are predictable. Tides keep time better than any calendar, which means that some of the most successful human communities of the Ice Age were living in places that are now underwater. That success is mostly invisible to us today, not because it never existed, but because it drowned. But before it drowned, the planet itself was remarkably stable. For nearly 80,000 years, the Ice Age climate persisted with relatively minor fluctuations. Cold, yes. Harsh in places, absolutely. But predictable. Ecosystems adapted. Plants optimized short growing seasons. Animals developed migratory routes spanning continents. Humans learned the rhythms of this world and fit themselves into it with impressive precision. The Ice Age was not chaos. It was equilibrium. And that equilibrium depended on ice staying frozen and water staying locked away. Which brings us to the unsettling part. All that ice did not sit directly on bedrock everywhere. As glaciers advanced and retreated, they reshaped the land, carving basins and blocking valleys. In many places, they created natural dams made entirely of ice. Behind those dams, meltwater collected. Not small lakes, inland seas. Bodies of water so large they rivaled or exceeded the size of modern Great Lakes systems. Lake Agassiz in North America, for example, covered an area larger than many countries and held more water than all of today's Great Lakes combined. Similar lakes formed in Europe and Asia along the margins of the ice sheets. These lakes were held in place by frozen barriers that seemed permanent, and for thousands of years they were. To the people living in the Ice Age world, the ice sheets must have felt eternal. They had existed longer than any story, longer than any remembered past. They were simply part of the geography, like mountains or the sky. No one wakes up expecting a mountain to move. But ice is not rock. Ice flows. Ice cracks. Ice floats. And ice melts from the bottom as well as the top. As Earth's orbital cycles slowly shifted, the amount of solar energy reaching the northern hemisphere increased. Summers became very slightly warmer, not dramatically, not noticeably within a human lifetime, but enough to matter to systems that had been balanced on a cold edge. For tens of thousands of years, the ice began to weaken. Not collapse. Not yet. Just weaken. Meltwater increased. Pressure built behind ice dams. The planet unknowingly was setting traps for itself. And this is where the Ice Age stops being a distant curiosity and becomes something more unsettling, because none of this was visible to the people living at the time. From the surface, the world still looked familiar. Seasons changed as expected. Herds migrated. Rivers flowed. The coast remained where it had always been, at least within living memory. The slow buildup of instability happened out of sight, beneath kilometers of ice, hundreds of kilometers away. If there is a lesson hidden here, it is an uncomfortable one. Stability can exist right up until the moment it doesn't. The Ice Age world was not doomed because it was harsh. It was doomed because it was delicately balanced. The very systems that had made it productive and predictable for so long were capable of failing catastrophically once enough pressure accumulated. Which brings us back to the obvious question. If sea levels were so much lower, if oceans were missing vast amounts of water, if entire landscapes were exposed and thriving, where did the water go? And more importantly, what happens when it comes back? That is where this story begins to move. And with that, we continue into the second chapter, a quiet journey to the places the ocean now keeps hidden, the lost lands beneath today's oceans. When we imagine land lost to the sea, we tend to picture drama, storms, waves smashing coastlines, sudden disaster, but most of the land that vanished at the end of the Ice Age did not disappear violently. It disappeared patiently. The sea did not rush in. It advanced. And it advanced across places that once felt permanent enough to be called home. Think of these places not as coastlines, but as countries. Not mythical realms, not legends, but functioning landscapes with rivers, seasons, food, and memory. They had names, even if we no longer know them. They had paths worn into the ground by feet that walked the same routes for generations. They were not waiting to vanish. They were simply in the way. Real estate was incredible back then. Unfortunately, the ocean had long-term plans. Let us begin in the shallow waters of the North Sea. Today, when you look at a map, Britain appears confidently detached, an island with a clear boundary, surrounded by water that feels inevitable. But during the Ice Age, that separation did not exist. Between Britain and continental Europe lay a vast plain now known as Doggerland. Doggerland was not a bridge. It was a country-sized landscape, rolling hills, wide river valleys, wetlands rich with birds and fish, forests that supported deer, wild cattle, and smaller game. Archaeological evidence dredged up by fishing trawlers tells us people lived here for thousands of years. Stone tools, bone fragments, worked antlers, the quiet debris of ordinary lives. You could walk from what is now England to Denmark without noticing anything remarkable about the journey. No sense of crossing, no awareness that this land would someday be erased. As sea levels rose, Doggerland did not drown overnight. First, the water table crept upward. Marshes expanded. Low ground became seasonal wetlands. Rivers slowed and widened. Then lagoons formed. Then bays. High ground turned into islands. Islands became shoals. Shoals disappeared. Generation after generation watched their world shrink, not with panic, but with resignation. The sea was not an invader. It was a neighbor moving closer. Eventually, there was nowhere left to stand. Now move your attention east and south, toward Southeast Asia. Today, this region appears fragmented, thousands of islands scattered across warm seas. But during the Ice Age, much of Southeast Asia was joined into a single massive landmass known as the Sunda Shelf. Malaysia, Indonesia, parts of Indochina, and western Indonesia were once connected by dry land. Rivers flowed across what is now ocean floor. Tropical forests covered plains that are currently hundreds of feet underwater. The South China Sea did not exist as we know it. It was land, and not marginal land. This was some of the most biologically productive territory on Earth. Warm, stable climates, rich soils, abundant fresh water, access to both inland and coastal resources, a place where humans could settle, adapt, and thrive without constant migration. As sea levels rose, the Sunda Shelf fractured slowly, first into peninsulas, then into large islands, then into archipelagos. Communities that once shared land routes found themselves separated by expanding straits. Some adapted by developing maritime skills, better boats, longer voyages, new ways of navigating and trading across water. Others did not. Isolation set in, cultures diverged, languages split, genetic lines separated. What had once been a connected world became scattered, not by war or collapse, but by water quietly filling the low places. Far to the north, another vanished land, once connected continents. Between Siberia and Alaska lies the Bering Strait, a narrow passage of frigid water that today feels like a definitive boundary. During the Ice Age, it was not water at all. It was Beringia, a broad grassland corridor stretching hundreds of kilometers. This was not an icy wasteland. It was a cold, dry steppe, rich in grasses and large animals, mammoths, bison, horses. Humans followed these herds across what felt like continuous land, unaware that they were crossing between continents. Beringia was not a migration route in the way we imagine highways or paths. It was home. People lived there. They hunted, gathered, raised families, and buried their dead. When sea levels rose, Beringia did not collapse into the ocean dramatically. It simply flooded, cutting off a connection that had existed for thousands of years. Once the water returned, the bridge was gone, and with it, a shared world split permanently in two. Now turn your attention south and west toward the Middle East. Today, the Persian Gulf appears as a shallow sea, calm and familiar. During the Ice Age, it was something entirely different. It was a river valley, a long, fertile basin fed by the Tigris and Euphrates rivers, extending far beyond their modern mouths. This valley would have been rich in freshwater, plant life, and animal resources, an ideal place for early human settlement. Some researchers have suggested that this drowned landscape may have been one of the earliest centers of human organization, possibly even early agriculture. We cannot be certain. The evidence is underwater. As sea levels rose, the Persian Gulf filled gradually, transforming a river valley into a sea. Communities living there would have been pushed northward into Mesopotamia. It is not difficult to imagine how memories of this displacement might survive. Stories of a fertile land destroyed by rising waters, of a world ending not in fire, but in flood. The geography changed. The stories remained. And then there is the Black Sea. Today it is a saltwater sea connected to the Mediterranean by the Bosporus Strait. During the Ice Age and for thousands of years afterward, it was a freshwater lake. Its surface sat far lower than the Mediterranean. Around its shores, human communities thrived, farming fertile soils and fishing calm waters. Then, as global sea levels continued to rise, the Mediterranean reached a critical threshold. Water spilled over. What followed was not a gentle mixing of seas. Geological evidence suggests a catastrophic inflow. Salt water pouring into the Black Sea basin at extraordinary rates. Water levels rising day by day, swallowing shorelines faster than people could retreat. Within a short span of time, a freshwater lake became a saltwater sea. Everything living in that ecosystem died. Settlements vanished beneath the waves. Forests drowned where they stood. To the people living there, this would not have felt like a regional flood. It would have felt like the end of the world. Now pause. None of these places were mythological. None were legendary in their own time. They were simply landscapes that existed at the wrong elevation during a moment of planetary change. They did not vanish because of storms, or earthquakes, or divine anger. They vanished because ice melted far away. The important thing to understand is that these lands were not destroyed by waves. They were erased by arithmetic. As ice sheets melted, water returned to the ocean. As water returned to the ocean, sea levels rose. As sea levels rose, low-lying land disappeared. Not because it was weak, not because it was flawed, but because gravity always wins. The ocean does not negotiate. And the process was not even. Sea level rise happened in pulses. Long periods of relative calm followed by sudden advances when ice dams failed and glacial lakes drained catastrophically. For generations, the coastline might seem stable. Then, within a lifetime, everything would be gone. People adapted as best they could. They moved inland, they built boats, they told stories, they marked high water lines, and watched those markers become meaningless. And still, the water kept coming. Which brings us to the crucial clarification. These lands did not disappear because of waves. They disappeared because ice, which had been holding the ocean hostage for tens of thousands of years, finally began to let go. And when ice melts, it does not do so politely. That is the part of the story we must now face. Because the ocean did not rise on its own. It was released. And now we move into the third chapter, where the ice does not melt as expected, and Earth begins doing something quietly unsettling. From a distance, melting sounds gentle, drips, streams, the soft idea of thawing. It suggests patience, control, and time. The end of the Ice Age, however, did not behave like a careful transition. It behaved like a system under pressure that finally ran out of excuses. The key mistake? is assuming that melting is smooth. It isn't. Ice melts in pulses, in fits, in sudden releases that follow long periods of deceptive calm. And nowhere is this more evident than in the vast glacial lakes that formed along the edges of the great ice sheets. Imagine a simple object, a cup with a hairline crack. You fill it with water, nothing happens. You place it in the freezer. The water freezes, sealing the crack from the inside. The cup feels solid again. It looks stable. It is not. That was the Ice Age world. As continental glaciers advanced and retreated over thousands of years, they carved deep basins into the landscape. Valleys were blocked. Rivers were dammed. Meltwater had nowhere to go, so it gathered behind walls of ice that were sometimes hundreds of meters thick. These were not lakes in the way we think of them today. They were inland seas. Lake Agassiz, the largest of them, covered an area larger than many modern countries combined. At its maximum extent, it held more water than all the Great Lakes of North America put together. Similar lakes formed elsewhere. Lake Missoula in the Pacific Northwest, Lake Ojibwe in Canada, massive meltwater reservoirs across Scandinavia and Siberia. They existed quietly for centuries, sometimes millennia. To anyone living downstream, there was no warning. The ice dams holding these lakes back were far beyond human sight, locked behind walls of glacier that felt as permanent as mountains. No one knew a reservoir the size of a sea was waiting uphill, and the ice dams themselves were strange structures. Unlike concrete or rock, ice floats. It deforms. It melts from below under pressure. As water levels rose, ice dams became increasingly unstable, not at the surface where they looked solid, but at their bases, where friction and pressure generated heat, even in freezing conditions. Cracks formed. Channels began to cut upward through the ice. Water seeped, then froze again when temperatures dropped. The damage did not disappear. It accumulated. This is the part people rarely imagine. Failure does not require constant melting. It only requires enough weakening, followed by a moment when conditions change. And conditions did change. As Earth's orbital cycles continued shifting, the northern hemisphere received more solar energy. Summers grew slightly warmer, not enough for anyone to panic, enough to matter. Meltwater increased. Pressure behind ice dams rose. The cups filled higher. Then something happened that would define the end of the Ice Age. The dams broke, not slowly, not gracefully, catastrophically. When an ice dam fails, it does not overflow. It collapses. Water does not trickle over the top. It punches through the weakest point, ripping channels wider with every second as warmer water melts ice from the inside. When Lake Missoula drained, the flood waters surged across the Pacific Northwest with unimaginable force. Entire landscapes were scoured down to bedrock. Channels hundreds of meters wide were carved through solid stone. Boulders the size of houses were lifted and transported for kilometers. This was not erosion, it was excavation. The floods did not last for weeks, some lasted days, some perhaps hours. The volume of water released was so immense that modern rivers look decorative by comparison. For a long time, geologists refused to accept this. Landscapes, they believed, could only be shaped slowly by steady processes acting over millions of years. The idea that water could carve such features so quickly seemed absurd. But the scars remain. Dry waterfalls taller than Niagara, ripple marks in stone large enough to be seen from space, valleys that make no sense unless something impossible happened. Something did, and Lake Missoula was not alone. Lake Agassiz drained and refilled multiple times as ice dams failed and reformed. Each release sent colossal pulses of fresh water toward the oceans, sometimes through the Mississippi River system, sometimes through the St. Lawrence, sometimes directly into the North Atlantic. Each outburst altered global sea levels. Each injection of fresh water disrupted ocean circulation. And this is where the story becomes quietly dangerous. Because these floods did not just reshape land, they interfered with the planet's climate machinery. The North Atlantic is home to a powerful system of ocean circulation that transports heat from the tropics northward. Warm, salty surface water flows north, cools, becomes denser, and sinks, pulling more warm water behind it like a conveyor belt. This system is sensitive. Fresh water is lighter than salt water. Dump enough fresh water into the North Atlantic, and the sinking process slows or stops. Heat transport weakens. The northern hemisphere cools. This is not theory, it is observable physics. And geological evidence suggests that massive freshwater pulses from glacial lake outbursts did exactly this. Around 12,900 years ago, just as the planet was warming, something interrupted the process. Temperatures dropped sharply across the northern hemisphere. Glaciers stabilized or even advanced again. Forests retreated. Tundra returned. This event is known as the Younger Dryas. It arrived suddenly, within decades, perhaps faster. Imagine living through that. One generation experiences improving conditions, longer summers, expanding grasslands. The next watches winter reclaim the land. The cause is still debated. Some propose a cosmic impact. Others suggest volcanic activity. But the strongest evidence points to freshwater disruption of ocean circulation triggered by glacial outburst floods. In other words, the ice did not just melt, it fought back. And in doing so, it made the eventual collapse even worse, because the Younger Dryas acted like a pause button. Melting slowed, ice dams stabilized temporarily, cracks froze shut, but meltwater did not disappear. It continued accumulating behind reinforced barriers. Pressure built for over 1,000 years. The cup was placed back in the freezer, but the water level kept rising. When the Younger Dryas ended, it ended abruptly. Temperatures rose sharply. Ice weakened everywhere at once. Dams that had been holding unprecedented volumes of water were suddenly exposed to warmer conditions than they had experienced in thousands of years. They failed in cascades. One dam collapsed, releasing a flood that destabilized the next. Multiple drainage events occurred in rapid succession across continents. Inland seas emptied into oceans. Sea levels jumped in pulses. This is why the end of the Ice Age feels so sudden in the geological record. It was not a single flood. It was a sequence of failures, each one louder than the last. For humans living downstream, these events would have been incomprehensible. Rivers that had flowed gently for generations suddenly rose beyond any known limit. Valleys became torrents. Plains vanished beneath walls of water. There were no warnings, no sirens, no maps showing upstream lakes held back by melting ice. Just the sound. A distant roar that did not stop. And then the water arrived. We have no written records from these people, only scars in stone and sediment, but it strains credibility to believe no one was caught. Entire communities must have vanished without trace, their campsites erased, their paths scrubbed clean. This is the uncomfortable truth. The Ice Age did not end with a ceremony. It ended with failure. Failure of structures that had seemed eternal. Failure of systems that had been stable longer than human memory. Failure that came not from aggression, but from accumulation. Ice does not melt politely when it has been storing the ocean for 80,000 years. It releases it. And when it does, the planet changes faster than anyone expects. Which brings us to the truly strange part of this story. Because just when the world seemed ready to settle into warmth, just when the floods had reshaped the land, just when the ice had finally begun to let go, the earth did something no one living at the time could have imagined. It got cold again. That pause, that sudden return of winter, would change everything that followed. And it is where this story turns in an unexpected direction. And just when the planet seemed ready to warm and settle, we enter the fourth chapter, where Earth does something unexpected and quietly presses the brakes. Up to this point in the story, everything has followed a logic we can accept. Ice melts when it gets warmer. Sea levels rise, floods happen, landscapes change. It is dramatic, yes, but still intuitive. Cause and effect feel familiar. And then the planet does something strange. Just as the Ice Age appears to be ending, just as temperatures rise and glaciers retreat, Earth abruptly stops. Not slowly, not cautiously. It stops the way a machine does when someone hits the wrong switch. Warming halts. Cold returns. This moment is known as the Younger Dryas, and it is one of the most unsettling climate events in Earth's recent history, not because it was the coldest, but because it was the most unexpected. Around 12,900 years ago, as the Northern Hemisphere was emerging from thousands of years of ice-dominated climate, temperatures dropped sharply. In some regions, average temperatures fell by 10 to 15 degrees Celsius. That is not a seasonal fluctuation. That is the difference between forests and tundra. What makes this event remarkable is speed. This cooling did not unfold over centuries. Ice core records from Greenland suggest it happened within decades, possibly even faster. In geological terms, this is an instant. In human terms, it is one lifetime. One generation waking up to a world that no longer behaves as promised. Imagine living through that transition. Your grandparents remember endless ice. Your parents remember things improving, longer summers, animals returning, forests creeping north. Then you grow up and watch those forests die back. Grasslands turn brittle. Winters stretch longer again. Glaciers stop retreating and begin to hold their ground. No one voted for this. No one planned for it. And no one at the time had any way of knowing why it was happening. From the planet's perspective, however, something very specific had gone wrong. The climate system is not driven by temperature alone. It is driven by circulation, by the movement of heat through oceans and atmosphere. And one of the most important systems on Earth lives in the North Atlantic. Warm water flows north from the tropics, carrying heat toward Europe. As it cools, it becomes denser and sinks, pulling more warm water behind it. This process, often called the Atlantic Meridional Overturning Circulation, acts like a planetary heating system. It is why Western Europe is warmer than other regions at similar latitudes. But this system has a weakness. It depends on salt. Fresh water is lighter than salt water. If enough fresh water enters the North Atlantic, it can sit on the surface like a lid, preventing dense, salty water from sinking. When sinking slows, circulation weakens. When circulation weakens, heat transport fails. And around the time the Younger Dryas began, the North Atlantic received an enormous influx of fresh water. Not rain, not melting snow from a hillside, but catastrophic pulses of glacial meltwater released from collapsing ice dams and inland seas, especially from North America. Billions of tons of fresh water poured into the ocean, enough to disrupt circulation on a hemispheric scale. The planet did not gradually cool. It stalled. The heating system shut down. And winter returned. The evidence for this event is written clearly in ice cores. When scientists drilled deep into Greenland's ice sheets, they expected to find gradual warming after the last glacial maximum. Instead, they found a sharp reversal. Chemical signatures shifted abruptly. Oxygen isotope ratios changed. Dust levels rose, indicating drier, colder conditions. This was not subtle. The Younger Dryas lasted roughly 1,300 years. For more than a millennium, the planet hovered in this strange limbo, not fully glacial, not fully warm. A paused world, a holding pattern. And during this pause, something important happened. The ice stopped melting quickly. But the water did not disappear. This is the part that matters. The Younger Dryas acted like a temporary repair on a damaged system. Cracks froze shut, ice dams stabilized, glacial lakes stopped draining catastrophically and began filling again. Meltwater still existed. Solar energy was still higher than during the peak of the Ice Age. The underlying warming trend never stopped. It was merely delayed. Water accumulated behind reinforced barriers. Pressure increased quietly. For over 1,000 years, the planet stored potential energy behind ice walls that had already proven vulnerable. This is why the Younger Dryas is often misunderstood. It is tempting to see it as a simple return to cold conditions, a reversal of progress. But in reality, it was a reset that made the eventual outcome far more extreme. The pause allowed the system to load itself. Like a river blocked by a dam that is slowly weakening while rainfall continues upstream. From the human perspective, the Younger Dryas would have been deeply confusing. There was no gradual descent into cold, no warning signs that could be read from the sky. The same orbital cycles that triggered warming were still in effect. The sun did not dim. The seasons still turned, yet the world refused to cooperate. Animals changed their migration routes again. Some species that had begun expanding their ranges retreated or declined. Human populations that had adapted to improving conditions suddenly faced renewed scarcity. Archaeological evidence from this period suggests stress. Settlement sites were abandoned in some regions. Diets narrowed. Mobility increased again as people followed shifting resources. This was not a time of expansion. It was a time of endurance. And importantly, this disruption came after people had begun adjusting to a warmer world, which made it worse. Adaptation is expensive. It takes time. It requires stability long enough for behaviors to settle. The Younger Dryas denied that stability. It pulled the ground out from under populations that had already reorganized their lives. This is one reason why the end of the Ice Age is not remembered as a clean transition. It was jagged. It stuttered, and it did not follow expectations. From a geological perspective, the Younger Dryas stands out as proof that Earth's climate can shift states rapidly when circulation systems are disrupted. It does not require slow, cumulative change. It requires a trigger and a system already under strain. By the end of the Younger Dryas, the ice sheets were still immense. The glacial lakes were larger than ever. Ice dams were holding back more water than at any previous point. The cup, once again, was full. Then, around 11,700 years ago, something changed. The freshwater lid dispersed. Ocean circulation resumed. Heat began flowing north again. And when warming returned, it did not creep. It surged. Temperatures rose faster than they had fallen. Some records suggest increases of several degrees within decades. In a geological sense, the climate snapped. Ice that had been stable for over 1,000 years found itself in a world it could no longer survive. The dams that had held through the pause were suddenly exposed to conditions beyond their limits. They began to fail, not one by one, but together. And this is why the Younger Dryas matters so deeply to the story of floods and drowned worlds. It did not cause the final catastrophe. It prepared it. By pausing melting while allowing water and pressure to accumulate, it turned a gradual transition into a series of violent releases. The problem with stopping ice melt is not that ice returns. It is that water waits. And when it is finally released, it does not ask permission, which brings us to what happens next. Because when the Younger Dryas ended, it did not simply restore warmth. It unleashed everything the pause had been holding back. And that release would reshape continents, drown coastlines, and push humanity into a completely new way of living. That is where the story turns from strange to irreversible. And when the pause finally ends, we enter the 5th chapter, where the ice lets go all at once, and the flood turns out not to be a story, but a process. When the Younger Dryas ended, it did not fade politely into history. It ended the way systems under pressure often do, suddenly, decisively, with consequences that could no longer be delayed. For more than 1,000 years, the planet had been holding itself in a careful pause. Ice sheets stabilized. Meltwater accumulated behind frozen barriers. Glacial lakes swelled quietly, growing larger than any freshwater bodies humans had ever seen. The system looked calm, but it was not relaxed. It was tense. Then the pause broke. Around 11,700 years ago, global temperatures rose sharply, not over centuries, not gradually enough to feel safe. In some regions, warming happened within a few decades, perhaps even faster. Ice that had survived a millennium of cold suddenly found itself exposed to conditions it could not endure. The result was not a gentle melt. It was collapse. Ice dams that had been holding back inland seas failed one after another, not necessarily at the same moment, but close enough that from a human perspective, it would have felt continuous. One failure destabilized another. Floodwaters undermined downstream barriers. Cascades formed. This was not rain for 40 days. This was physics losing patience. When these ice dams failed, they did not release water in manageable quantities. They unleashed volumes measured in tens of thousands of cubic kilometers, entire lakes drained in a matter of weeks, sometimes days. Water surged across landscapes with a force no river could ever match. The Missoula floods are the most famous example, but they were not unique. Similar outburst floods occurred across North America, Northern Europe, and Asia. Each one reshaped terrain, carved channels, transported sediment, and erased anything fragile enough to stand in the way. These were not localized disasters. They were continental events, and the water had somewhere to go. It went to the sea. Every massive outburst flood raised global sea levels by measurable amounts, not inches spread over centuries, but feet added in pulses. Then came periods of relative calm, then another release, then another. Over the course of several thousand years, sea levels rose by approximately 120 meters, or about 400 feet. That number is easy to say and difficult to feel. 120 meters is not a shoreline adjustment. It is the drowning of entire landscapes. It is the transformation of plains into seafloor. It is the erasure of coastlines that had existed for tens of thousands of years. And it did not happen evenly. Sea level rise was punctuated. Long stretches where the ocean seemed stable were followed by sudden advances when glacial systems failed. To people living at the coast, this would have been profoundly disorienting. Imagine living in a village that has existed in the same place for generations. The tide comes and goes predictably. The shoreline moves a little each season, but always returns. Then one year it doesn't. The next year the water reaches places it never has before. A decade later, familiar paths are gone. Marshes form where solid ground once was. Another generation passes, and what was once a village becomes a memory, then a reef, then silence. This was not a single flood story told once and remembered. It was a process endured repeatedly. And here is the crucial point. When sea levels rise by hundreds of meters, mountains do not vanish. People do. High ground survives. Hills remain hills. Mountains still pierce the sky. What disappears first are lowlands, river valleys, coastal plains, the places where humans actually live. This is why the archaeological record feels incomplete. The most successful human communities of the late Ice Age were not living in caves high in the hills. They were living near water, along coasts, in deltas, in estuaries, on continental shelves that are now submerged beneath oceans. As the sea rose, those places were erased, not burned, not conquered, not abandoned in haste, drowned. And drowned places do not preserve easily. Wood rots, organic material disperses, stone structures collapse under sediment. What remains is scattered, fragmented, difficult to interpret, which means we are missing enormous portions of human history. This is not speculation, it is geometry. When sea levels were 120 meters lower, vast areas of continental shelf were exposed. Today, those areas are underwater. Any settlement built there is now inaccessible without specialized equipment, if it survives at all. In some regions, underwater archaeology has revealed glimpses of what was lost. Submerged forests with trees still rooted where they grew, stone tools lying where they were dropped, walls, hearths, paths frozen in time beneath layers of sediment. These discoveries are rare, not because such sites were rare, but because the ocean is very good at keeping secrets. Now consider the psychological experience of this process. This was not a disaster that arrived in a single night. It unfolded over generations. People watched the world change slowly enough to normalize, but fast enough to be irreversible. Each generation inherited a smaller version of the world than the one their grandparents described. This creates a unique kind of trauma. Not the shock of sudden destruction, but the exhaustion of slow loss, the constant calculation of whether to move now or later, whether the water might stop, whether adaptation will be enough this time. Some communities moved inland early, others stayed as long as possible. Archaeological evidence suggests continuous occupation right up until the final drowning in many coastal areas. People did not abandon their homes at the first sign of danger. They adapted. They raised floors. They shifted fishing grounds. They learned new routes. They hoped. Hope, in this context, was expensive. Eventually, hope ran out of land. As coastlines retreated, displaced populations moved inland, often into territories already occupied by others who had been displaced earlier. This created pressure, competition, conflict, integration, migration on a scale humanity had never experienced before. The flood did not just reshape geography. It reshaped society. As populations were pushed into smaller habitable areas, old patterns of mobility became unsustainable. The era of endless space ended. People encountered each other more frequently. Resources overlapped. Choices narrowed. This is one of the reasons the post-flood world looks so different from what came before. But before we get there, it is important to understand just how dramatic the physical changes were. Meltwater pulses are clearly visible in geological records. One of the most significant, known as Meltwater Pulse 1A, occurred around 14,600 years ago, raising sea levels by as much as 20 meters in less than 500 years. That is an average of 4 centimeters per year, enough to watch the shoreline move in real time. Another pulse followed near the end of the Younger Dryas. Each pulse overwhelmed ecosystems, reconfigured coastlines, and forced rapid adaptation. This was not a stable rise. It was a staircase, and each step erased another world. It is important to emphasize that none of this required supernatural explanation. No divine anger, no singular cataclysm, just ice, water, gravity, and time. The planet was shedding an ice age, and shedding is not tidy. The flood stories that would later appear in human cultures did not originate from a single event. They emerged from repeated experiences of loss, displacement, and survival. When people describe water covering everything, they are describing their entire known world, not the entire planet. If your valley, your coast, your hunting grounds, your ancestors' graves all vanish beneath water, it does not matter that mountains still exist somewhere else. For you, the world has ended, and yet humanity survived. Not comfortably, not without loss, but persistently. Small groups reached high ground. Others adapted to river systems. Some learned to exploit new marine environments as coastlines stabilized temporarily. Knowledge moved with people, technology spread, stories were told, but much was lost. We tend to frame the end of the Ice Age as a beginning, the dawn of agriculture, the rise of civilization, and in many ways that is true. But it is also the aftermath of a disaster. Civilization did not emerge from abundance alone. It emerged from constraint, from forced proximity, from the need to manage water that no longer behaved as expected. The flood did not end, and then civilization began. They overlapped. The flood was still reshaping coastlines while humans were learning to settle river valleys, while early farming experiments began, while new social structures formed. This overlap is why flood memories are so persistent in early cultures. These were not distant myths. They were lived experiences still unfolding. And importantly, the flood was not over quickly. Sea levels continued rising until roughly 7,000 years ago, when they stabilized near modern levels. For thousands of years, coastlines were provisional, temporary, subject to revision. By the time stability returned, the world map had changed completely. The lands described earlier, Doggerland, Sunda, Beringia, drowned river valleys, were gone, not hidden. Gone, and humanity had been pushed into a narrower world. Which brings us back to the transition we are about to explore. Because once the water finished rising, the planet did not return to how it was before. It entered a new phase, one where humans could no longer simply move away from problems, one where adaptation required planning, cooperation, and control. And that is where the flood stops being a geological process and becomes a human one. Because when the water rises, the first thing to disappear is not mountains. It is people. And what they are forced to become next will shape everything that follows. And as the water settles, we move into the 6th chapter, where the world does not end loudly, but disappears quietly beneath the surface. When people imagine lost civilizations, they tend to imagine ruins on land, broken columns, deserted cities, stones standing defiantly against time. We expect the past to leave something behind. The drowned world did not. It left absence. This is the uncomfortable truth beneath our understanding of early human history. The places where humans lived most densely for tens of thousands of years were not inland plateaus or high mountain valleys. They were coastlines, river mouths, estuaries, continental shelves where land and sea met gently and predictably. That is where food was reliable. Shellfish did not migrate. Fish returned with the seasons. Freshwater flowed nearby. Transportation was easier. Climate was moderated by the sea. If you were choosing where to live during the Ice Age, evolution made the choice obvious. So humans gathered along the edges of the world. And when the sea rose, those edges vanished first. It is estimated that up to 90% of Ice Age coastal archaeological sites are now underwater, not buried beneath cities or forests, but submerged beneath continental shelves that stretch for kilometers beyond modern shorelines. This is not a mystery, it is geometry. When sea levels were lower, those shelves were dry land. When water returned, they drowned. Everything built there drowned with them, which means that the archaeological record we study today is not a complete record. It is a survival record. What we have left on land are the places people fled to, not the places where they thrived the longest. This creates a subtle distortion in how we imagine early humanity. We see inland caves, temporary camps, scattered tools, and assume scarcity. But the most stable, resource-rich environments, the places where people likely lived continuously for thousands of years, are now out of reach, resting beneath layers of sediment and salt water. The silence of the drowned world is not because it never spoke. It is because it is underwater. Underwater archaeology has begun to reveal fragments of what was lost, but only fragments. Submerged forests with tree trunks still rooted in place, stone tools lying on ancient surfaces, hearths, walls, pathways, frozen at the moment the sea arrived. In some places, trees still stand upright on the seafloor, preserved by cold, oxygen-poor water. They did not fall. They did not rot. They were simply overtaken. These are not fossils. They are reminders. Carbon dating of these submerged forests tells a consistent story. They grew on dry land. They lived through centuries of stability. And then, within a relatively short time, they drowned. Not because storms tore them down, but because the shoreline moved past them and did not stop. In a human lifetime, a forest became a seabed. That is how quietly this world ended. And because it ended quietly, it did not announce itself as catastrophe. There was no single day everyone remembered, no universal marker that said, "This is when the old world ended." Instead, there were countless small endings. A fishing ground that no longer surfaced at low tide, a burial site that became marshy, a path that required a boat, a home abandoned because the floor never dried. Loss accumulated. The people who lived through this were not ignorant. They could see what was happening. The water rose slowly enough to be noticed, but fast enough to be relentless. Every generation knew more land would be lost. The question was not whether, but when. This created a kind of patience that is difficult for us to imagine. People stayed longer than logic might suggest. Archaeological evidence shows continued occupation right up until the final inundation in many coastal areas. Tools and dwellings were not removed in haste. They were left behind carefully, as if their owners believed they might return. They often did not. And then the sea closed over everything. Once submerged, the ocean does not preserve history the way dry land does. Waves scatter debris. Currents bury structures under layers of sediment. Organic material decomposes. What remains is fragmented, displaced, anonymous, which is why underwater archaeology feels like listening to history through a wall. Sonar mapping reveals ancient river channels now buried beneath the sea, submerged shorelines traced by changes in sediment, stone structures detected but difficult to interpret. Every discovery suggests not a single lost site, but an entire missing chapter, or several. And because these chapters are missing, our understanding of human development feels strangely abrupt. Agriculture appears suddenly. Permanent settlements emerge quickly. Social complexity seems to accelerate. It is tempting to call this progress, but it may also be recovery. The drowned world did not leave behind its blueprints. Knowledge carried by people who fled inland survived, but much that was embedded in place, coastal technologies, navigation routes, long-term ecological knowledge, did not. We are looking at the aftermath of loss and calling it a beginning. This is not a tragedy in the dramatic sense. There is no villain, no moment of collapse to replay, just the slow erasure of a world that functioned well enough to last tens of thousands of years. And because it functioned quietly, it ended quietly too. The people who lived along these coasts were not necessarily primitive. They had intimate knowledge of tides, seasons, marine life, and land-sea interactions. They likely developed watercraft earlier than inland populations. They probably navigated by stars and currents long before written records. Much of that knowledge did not transfer cleanly inland. When people fled to higher ground, they entered environments with different rules. Rivers replaced tides. Forests replaced shorelines. The skills that had sustained coastal life were not always useful there. This is another reason the transition was not smooth. The drowned world did not collapse and then get replaced. It receded, and what followed had to improvise. Underwater archaeology occasionally gives us a glimpse of how sudden some losses were. Tools found where they were dropped, structures that show no signs of gradual abandonment, places where daily life appears to have been interrupted rather than concluded. But even these moments are difficult to interpret. Water hides context. We do not know whether people left because they saw the water coming or because their resources disappeared first. We do not know how many returned briefly, hoping conditions had stabilized. We do not know how many watched their former homes from boats before abandoning them forever. What we do know is this. For thousands of years, humanity lived with the understanding that land could disappear. Not metaphorically. Literally, that understanding shaped behavior, movement, and memory. And memory is where this story continues. Because while stone dissolves and wood rots underwater, stories do not. They move. They follow people inland. They change shape, but they retain a core truth, that the world was once larger, that the sea moved, that land was lost, that survival required adaptation. The drowned world did not leave monuments. It left migrants. It left displaced families carrying knowledge, habits, and warnings. It left children who grew up hearing about places they would never see. It left elders who remembered shorelines that no longer existed. And those memories mattered. They mattered enough to be repeated, enough to be ritualized, enough to survive thousands of years without writing. This is why flood stories appear again and again across cultures that had no contact with each other. Not because humans are imaginative in the same way everywhere, but because they experienced the same loss in different places. The details differ. The gods change. The morals shift. But the structure remains. A world that existed. Water that rose. Survivors who escaped to higher ground. A before and an after. These stories were not invented to entertain. They were preserved because forgetting them would have been dangerous. Knowing that land can vanish changes how you think about permanence, about settlement, about where to build, about what to trust. The drowned world taught humanity something uncomfortable. That stability is temporary. That even the ground beneath your feet has a memory shorter than you do. But it did not teach this lesson with violence. It taught it slowly, quietly, wave by wave. And when the water finally stopped rising, the world that remained was narrower, more crowded, and less forgiving. Which is why the next part of the story does not begin with forgetting. It begins with remembering, because although the drowned world left very little behind for archaeologists, humans did not let it disappear completely. They carried it forward in stories. And that is where we go next, because people do not forget the world that drowned. They tell it. And once the water grows quiet, we move into the 7th chapter, where what remains is not land, but memory. Once the water stopped rising, something unexpected happened. People talked. Not immediately and not loudly. There was no global announcement that the old world was gone. But stories began to circulate. At first they were practical. Where the shoreline used to be. Which valleys flooded fastest? Which places were no longer safe to return to? These were not myths. They were instructions. Over time, instructions became memories. Memories became stories. Stories became traditions. And those traditions traveled. This is why flood stories appear almost everywhere humans settled after the Ice Age, not in one region, not in one culture, but across continents that never spoke to each other: Mesopotamia, South Asia, East Asia, the Americas, Australia, Africa, islands separated by oceans that, ironically, did not exist when the stories began. The similarity is unsettling. Almost every culture remembers a world before the water. Almost every culture remembers survival through higher ground. Almost every culture remembers loss that feels total, even if it wasn't planetary. This does not require coincidence. It requires memory. Before writing, before stone inscriptions, before calendars, humans relied on stories to preserve information across generations. Stories were not entertainment. They were storage. Stories were the cloud storage of prehistory. They backed up what mattered. In societies without permanent records, oral tradition had to be resilient. It had to survive migration, displacement, famine, and time. That meant stories could not be fragile. They needed structure, repetition, emotional weight. A flood story does all of that. It explains why old places should not be trusted. It warns that water can rise beyond expectation. It justifies moving inland. It teaches respect for rivers and coastlines. It reminds people that stability is conditional. And importantly, it compresses long, slow processes into a narrative that can be remembered. No one remembers sea level curves. Everyone remembers a flood. This is where modern misunderstandings often begin. Flood myths are frequently dismissed as exaggerations, metaphors, or moral parables invented to explain natural disasters. But this assumes that early humans were trying to explain nature philosophically. They were not. They were trying to survive. If your grandparents lived on land that no longer exists, and your parents fled rising water, and you grew up inland hearing those stories, you would not tell them as technical reports. You would tell them as warnings. You would simplify. You would dramatize just enough to make sure they were never ignored. This is how memory stays alive without writing. The details shift over time. Gods appear. Heroes emerge. Moral lessons are added. But the core remains remarkably consistent. There was land. Water rose. Survivors escaped. Everything changed. From a scientific perspective, this consistency is not suspicious. It is expected. Human memory does not preserve data. It preserves meaning. And the meaning here was clear. The world you inherit is not permanent. This does not mean flood myths describe a single global event. That idea misunderstands both geology and memory. Sea level rise occurred over thousands of years, not days. Flooding was regional, not planetary. Different cultures experienced different losses at different times. But the psychological impact was similar. Each group experienced what felt like total loss of their known world. When your entire landscape disappears beneath water, scale becomes irrelevant. Whether the flood covered a valley or a continent does not matter. What matters is that it covered everything you knew. That is what survives in story. Anthropologists and archaeologists increasingly recognize that oral traditions can preserve accurate information for astonishing lengths of time, especially when tied to geography and survival. Indigenous stories describing volcanic eruptions, earthquakes, and coastal flooding have been shown to correspond with real events thousands of years old, not because the stories are exact records, but because forgetting them would have been dangerous. Flood stories persist because they encode behavior. Do not settle too low. Do not trust calm water blindly. Listen to elders who remember change. Move when signs repeat. These are not poetic lessons. They are practical ones. There is also an emotional reason flood stories endure. They offer continuity. For people displaced by environmental change, stories connect the present to a lost past. They allow communities to acknowledge loss without needing physical remains. When land is gone, memory becomes territory. Telling the story is a way of saying, "We were there." And being there matters. This is especially important in the context of the drowned world. As discussed earlier, most coastal sites vanished without trace. No monuments, no ruins, no visible scars, just water. Without stories, it would be as if those places never existed. Flood myths push back against that erasure. They insist that something was there, and that someone remembers. The slight humor we detect in some versions, animals saved, boats built just in time, improbable survival, is not accidental. Humor makes stories repeatable. It reduces fear while preserving caution. It allows people to talk about loss without becoming paralyzed by it. If the story were only tragedy, it would be told once and avoided. Instead, flood stories include survival. Someone lives, someone rebuilds, someone tells the story again, and that matters. Because memory without survival is just grief. Memory with survival is instruction. From a neurological perspective, this makes sense. The human brain is not optimized to remember neutral information across generations. It remembers emotionally charged narratives that resolve in meaning. Flood stories do that. They explain why the world looks different than it used to. They explain why certain places are avoided. They explain why rivers are respected. They explain why ancestors moved. And they do all of this without requiring maps, charts, or numbers, which is why the scientific dismissal of myth often misses the point. These stories were never meant to explain the physics of melting ice. They were meant to explain why the land cannot always be trusted. And that is something science eventually confirmed. Only much later did humans develop the tools to measure sea level rise, reconstruct paleoclimate, and understand glacial dynamics. But long before that, people already knew the outcome. The water comes back. It always has. The fact that these stories survived at all is remarkable. They endured migration, cultural change, conquest, and time. They adapted to new belief systems. They were retold in new languages. They absorbed new meanings, but they never disappeared. This persistence suggests that they were not optional, they were necessary. They were reminders of a truth that shaped post-Ice Age humanity, that survival depends not only on adapting to the present, but on remembering the past accurately enough to avoid repeating its mistakes. And after all that remembering, something new began to take shape. Not immediately, not everywhere, but slowly as people settled inland, clustered around rivers, and realized that movement alone would no longer solve every problem. The flood had ended. The water had stopped rising. The world had narrowed, and in that narrower world, humans began doing something they had rarely needed before. They began staying put. Which brings us to what emerged from loss, because after everything that disappeared, something new appeared. And it would define the next chapter of human history. And after the stories settle into memory, we move into the 8th chapter, where survival turns into routine and movement slowly becomes staying. After the floods, there was no grand decision. No meeting where humans collectively agreed to invent agriculture, build villages, or start civilization. There was only pressure, slow, persistent pressure, applied not by enemies or gods, but by geography. The water had taken the edges. The coastlines where people had lived for thousands of years were gone. The gentle zones where land and sea met, where food came from many directions at once, where movement was easy and seasons were forgiving, had narrowed or disappeared entirely. So people moved. At first, this movement looked familiar. Groups followed rivers inland just as they always had. They camped, they hunted, they gathered. They expected, as generations before them had, that movement itself would remain the solution. But something had changed. The interior was already occupied. Not empty wilderness, but landscapes increasingly crowded by others who had arrived earlier, pushed inland by earlier pulses of water. The further one moved from the drowned coasts, the fewer choices remained. The world had become smaller. And for the first time in human history, leaving was no longer always an option. This is the quiet pivot point. When movement stops being easy, staying becomes necessary. Staying requires planning. Planning requires predictability. And predictability requires control. This is where agriculture enters the story, not as an invention born of insight, but as an adaptation born of constraint. Humans had known plants intimately for tens of thousands of years. They understood seasons, growth cycles, soil, and water. They had selectively harvested, protected, and even encouraged certain species long before farming began. What they had not needed to do was rely on plants completely. Now they did. Settling near rivers was not a choice made for beauty or symbolism. Rivers offered what coastlines once had: reliable water, fertile sediment, and predictable cycles. But rivers also came with a problem. They flooded. And unlike the great floods that erased coastlines, these floods returned every year. This regularity changed everything. Seasonal flooding deposited nutrient-rich silt, creating soil that produced extraordinary yields with minimal effort. Seeds scattered after floodwaters receded grew better than anywhere else. People noticed, not immediately as agriculture, but as convenience. Food growing where camps already were. plants returning where waste had been discarded, harvests becoming predictable. Over time, predictability replaced mobility as the primary survival strategy. This transition did not happen everywhere at once. It happened independently in multiple river valleys, each responding to the same underlying pressures created by post-glacial flooding: the Tigris and Euphrates, the Nile, the Indus, the Yellow River. Different climates, different plants, same logic. Stay near water, use the flood, survive the dry season. But staying put introduced a new problem. Food could now be stored. Stored food changes social dynamics instantly. When food can be stored, it can be stolen. When it can be stolen, it must be protected. When it must be protected, someone must decide who guards it, who distributes it, and who gets access. This is not ideology. This is logistics. Agriculture did not create surplus to make life easier. It created surplus that had to be managed. Management requires authority. Authority requires structure. Structure requires rules. And rules, once established, tend to stay. This is how temporary camps became permanent villages. Villages became towns. Towns became administrative centers. Not because humans suddenly wanted hierarchy, but because surplus demanded coordination. Water management accelerated this process. Floodplain farming is productive but dangerous. Too much water destroys crops. Too little kills them. Timing matters. Coordination matters. Someone had to decide when canals were opened. Someone had to organize labor, to build levees. Someone had to measure flood height and predict outcomes. These were not ceremonial roles. They were survival roles. The earliest governments were not kingships or priesthoods. They were water management systems. The first bureaucracies tracked grain. The first calendars tracked floods. The first engineering projects controlled rivers. And the first large-scale social cooperation emerged not around temples, but around irrigation. This is why early civilizations look so similar despite emerging independently. They all obsess over water. They all record floods. They all fear drought. They all develop tools, mathematics, and writing initially to manage resources, not to tell stories. Writing begins as accounting. Mathematics begins as measurement. Architecture begins as storage. None of this is romantic. It is practical, and it is born directly from the constraints imposed by rising water. The loss of coastlines forced populations into closer proximity. Proximity forced cooperation. Cooperation required systems. Systems became civilization. The irony is subtle. Civilization is often portrayed as humanity's great ascent, a triumph of ingenuity over nature. In reality, it began as a defensive posture. Humans did not conquer nature. They retreated from it inland and learned to negotiate with what remained. The sleep-friendly humor here writes itself. Civilization began because humans ran out of coastline, not because they dreamed of cities, but because the ocean had already claimed the alternatives. This shift also changed human psychology. Nomadic life encourages flexibility. Settled life encourages ownership. When land becomes fixed, boundaries matter. When boundaries matter, conflict changes. Territorial disputes replace migratory avoidance. Defense becomes permanent. Violence becomes organized. This is not a moral judgment. It is an outcome. But it also creates new possibilities. Permanent settlements allow specialization. Not everyone needs to gather food anymore. Some can make tools. Some can build. Some can observe the sky. Some can remember. This concentration of skill accelerates innovation. Within a few thousand years, technologies appear that had no parallel in the mobile world. Pottery, metallurgy, writing, monumental architecture. None of these would be possible without stable food production, and stable food production would not exist without flood-altered landscapes. Even religion shifts in response. Flood myths evolve into agricultural cosmologies. Gods control rain, rivers are sacred, floods are punishment or renewal. These beliefs reflect lived reality. Water determines survival. The past flood becomes the template for future fear, and memory becomes theology. What is often called the Neolithic Revolution was not a sudden leap forward. It was a forced reorganization, a narrowing of options that made staying the least bad choice. From that constraint, complexity emerged. And complexity, once established, does not easily reverse. By the time sea levels stabilized near modern levels, humans were already locked into a new way of life. The drowned world could not be returned to. The inland world had become permanent. Civilization did not erase memory of the flood. It institutionalized it. Flood stories persisted. Water rituals emerged. Cities were built with walls, not just against enemies, but against rivers. Every major early civilization carries the imprint of water anxiety. This is not coincidence. It is inheritance. And now, as this long arc draws toward its quiet conclusion, one final realization settles in. The flood did not end humanity. It reshaped it. It compressed populations. It forced cooperation. It demanded foresight. It rewarded memory. And it left behind a species uniquely sensitive to water, change, and loss. Which brings us to the last question. After all the ice melted, after the seas rose, after the old world drowned and the new one formed, what does this story mean now? That is where we end, not with disaster, but with reflection. And after people learn to stay, to plant, and to build, we arrive at the final chapter, where the story does not end, but settles. By the time the oceans finally stopped rising, there were no witnesses left who remembered the old shores clearly. No one alive could point and say, "This was once dry land. This was a forest. This was a path. This was home." The sea had finished its work quietly, not with a final wave, not with an announcement, just with stillness. And humans, as they often do, adapted to what remained. They built where the water no longer reached. They learned which rivers could be trusted and which could not. They marked flood lines. They told stories. They planted. They stayed. What is easy to forget looking back from the present is how narrow that decision really was. Staying was not chosen because it was better. It was chosen because it was all that was left. The world had shrunk. The coasts were gone, the shelves were underwater, the easy exits had closed. So humans did something unprecedented. They accepted limits. They accepted borders. They accepted seasons they could not walk away from. They accepted the risk of building something that could be lost again. And in doing so, they changed forever. Civilization, at its core, is not a celebration of progress. It is a record of compromise. A compromise with water, with land, with time. Every wall ever built is an answer to a flood. Every granary is an answer to hunger after displacement. Every city is an answer to the question, where do we go when there is nowhere left to go? This is why the memory of the flood never disappeared, even as writing replaced oral tradition, even as science replaced myth, even as maps became precise and coastlines stabilized. The unease remained. It is embedded in language, in religion, in law, in architecture. We still build cities near water, but we do not fully trust it. We still depend on rivers, but we try to control them. We still tell stories about rising seas, because somewhere deep in human memory is the knowledge that the ground beneath us is conditional. That knowledge is not panic, it is awareness. And awareness, when remembered quietly, is not frightening. It is grounding. The people who lived through the end of the Ice Age did not know they were creating the modern world. They were simply trying to survive a changing one. They did not plan civilization. They stumbled into it. They did not predict agriculture. They leaned on it. They did not invent governments. They organized food and water. Everything we call history grew out of that moment when movement stopped being enough. And here we are now, living on coastlines again, building cities near rivers again, trusting systems again, telling stories again. We are not different people. We are later people. The oceans we look at today are not strangers. They are return visitors, patient, predictable, unimpressed by our confidence. But there is something quietly reassuring in this long story. Humans have faced this before, not abstractly, not symbolically, literally. They lost land, they lost homes, they lost entire worlds, and they adapted, slowly, messily, imperfectly, but enough. Enough to remember, enough to rebuild, enough to pass the story on. So if tonight, listening to waves or silence or nothing at all, you feel a strange calm in knowing how old this story really is, that makes sense. The ocean has been here longer than us, and we have been responding to it longer than we realize. This is not the end of the story, and it never was. It is simply another quiet moment where the water rests, and so do we. Now there is nothing left to explain, only to rest. Good night.